All right, so we're going to continue here to work on building an understanding of what the derivative can tell us about a function. So make sure you understand this problem we're going to consider here. Make sure you've read it. Make sure you know what s of t is and what t is in this problem. Ignore the fact that I spelled squirrel wrong here, and we'll just pretend that didn't happen. And make sure, most importantly, you have a good mental image of what is happening here. We've all seen this in real life at some point, I think, right? So the squirrel is running along a wire. So if I'm this squirrel, I can only really move in one direction or the other. So that's the type of problem we're considering. It's motion along a line, right? So I can only go left and right because if I go forward or back, I fall. So what's nice about this type of problem is we can analyze this problem using a number line, right? So imagine my number line is the wire, and we're just going to figure out where the squirrel is. So S tells us where the squirrel is. S represents position. And if we want position at 0, 2, and 3, well, I want S of 0, S of 2, S of 3. So this would be a great thing to do along with me on your calculator. So I typed in my function exactly as I see it, except for with x instead of t. And then I'm going to do second calc value. And you don't need to do this, obviously. You could do this by hand. But this will just make it real fast. So I'm going to type in 0. So S of 0 is 5. And then I'm going to type in 2. I get negative 3. And then I'm going to type in 3, which is negative 4. So we made a table of values here. And this is going to help us plot our positions. So remember, our number line represents position, represents S. So we want to find the y values essentially, right? So at time 0, our squirrel is all the way over here at the right. So here's t equals 0. We're standing over here at 5. And then t equals 2, we're at negative 3. So that's over here. And it looks like at t equals 3, we're at negative 4, so we've moved a little bit to the right here. So this gives us a sense of how the squirrel is moving, right? So I started over here, and the squirrel is moving to the left, it looks like. Okay. And again, I just got these values by my position function here. Okay, now we're asked for the table of values for v of t. So if you've taken physics, this is going to start to sound familiar. If not, this is going to be a little bit newer. But if you ever take physics, you're going to be ready. So v of t represents velocity. And velocity essentially means, don't ask Mr. Seymour about this, but what it essentially means is speed with a direction. Okay. In physics, you probably have a more precise definition for it, but that's good enough for us. Speed with a direction. So we're going to use our calculator to figure out a little bit of information about v of t, which is essentially how position is changing, right? So v of t is the derivative of s of t. So we want to fill out this table, and the way we're going to do that is using the derivative function on our calculator for now. So I still have s typed in. I'm going to get out of my grapher, and then I'm going to do math and then 8 to get my derivative operator, derivative with respect to x. And then I want to use that function I already have. So I'm going to use yvars, y1. And then let's just start, we want to make a graph, so let's just start plugging in x values. So we'll start with maybe negative 3. And that spits out negative 12. And then maybe we'll do the same thing again, but we'll use negative 1. And we're going to keep going. And then we're going to keep going like that. You don't necessarily have to use the same values of me, but we should use some positive x values and some negative ones just to get a sense of what this looks like. And then we're going to make a little table and sketch a graph. So here's my table of values for v. And again, yours doesn't have to include the exact same t values, but for every t value that you have that I have, your v should match. So make sure your calculator is spitting out the same numbers as mine, essentially. And then we can sketch a graph. And notice, like, I don't really have enough space to produce this. I know I can make 3, 0. And I know I can make 5, 4 is way up here. And then I know my velocity is going to be roughly negative, and I should cross the y-axis somewhere way down by negative 6. So that looks about right. Okay, so here's my velocity graph. Let's label this graph v of t. And we can use this to answer some questions here. So the questions are, when is the squirrel moving left? And when is the squirrel moving right? So we're kind of figuring out when this squirrel changes directions. Well, we already know the squirrel was moving left at 0, 2, 3 for t, right? So that was here, here, here. And notice those are all values where my velocity is negative. So moving left is wherever v of t is less than 0. And that kind of makes sense, right? Because left is like a negative direction on our number line, right? So left is over here. So what we can say is for t is less than 3, the squirrel is moving left. So that would be my answer here. And then squirrel moving right, well, that would be everywhere over here, right? So that would be t is bigger than 3. And then at rest means not moving, right? So at rest, well, that would be t equals 3 because v of 3 is 0. So my velocity is 0 when I'm at rest. My speed at t equals 1. So speed is a little bit different than velocity, right? So imagine we put a speedometer on this little squirrel. We want to know what it says when t equals 1. Well, my velocity was -4. But we never say we're going -4 miles per hour, right? That doesn't make a whole lot of sense in real life. Speed is always positive. So we're going to say at t equals 1, we'll say b of t is -4. So speed is 4, and I give you units. It's okay if we didn't. 4 yards per minute from the problem. Okay. So that gives us another definition. Let's pause for a second before we consider these last couple problems and fill in our definitions. So we have speed. Well, what did we just do? We took the absolute value of velocity, and then we never really talked about what position means. Position means essentially it's a distance from a 0 point. So if I ask you where we are, it doesn't make sense to say I'm like 4 miles, right? We would say 4 miles from home. So we have to give it in relation to a 0. That's why this has a sign. And then finally, we're asked about v prime of 1. So v prime of 1 is the derivative of v, how velocity is changing. If you had physics, you know this word. If not, it's new, but you've heard this word before. This is acceleration, is the rate of change of velocity. So really, this problem is asking us for the slope of v. It's a derivative, right? At t equals 1. And if we look at our graph, it's kind of hard to see depending on how nicely you sketched it, but my slope is 2, positive 2. So we go up 2 over 1, up 2 over 1, and my sketch is rough. Or you can also pick 2 points. So if I calculated the slope between these 2 points, for example, and it doesn't matter which points we pick because it's a line, we have my slope is 2. So it's how velocity is changing. So what this means is my acceleration is 2, or velocity is increasing at 2 yards per minute, right? Y is per x. And then speeding up or slowing down, well, speed is the absolute value of velocity. So we only care about how far speed is from 0, how far velocity is from 0. And notice at t equals 1, my graph is getting closer to 0, right? So towards the 0. So we're slowing down, and that can be your reasoning. Okay, and there is a trick to figuring that out more generally, which we'll explore as you do the work for this lesson. What we're going to do now is just try to apply what we've learned. So I have a problem on the next page. I'm going to give you the solutions in a few seconds. So I would say try it on your own is the best way to engage. So here are the solutions to our example problem. Hopefully you try these on your own and your answers match mine. Double check them. If you have questions on this problem, it's the same as the last few problems of our squirrel problem. If you're unsure about it, find me IRL before you start your practice. So there was a lot in this lesson, a lot of new definitions. Still just working with derivatives though. We're going to fill out this glossary as we go. to help make your life a little bit easier. So find this in the last page.